students, now welcome back to the new module of our chapter called Magnetism. In this particular module, we'll be focusing on very important term called as magnetization. Now this magnetization is given by symbol MZ, students, right? Now this particular term we have already introduced in the previous module. Do you remember? Yes, we have already learned that every magnetic field has got ability to magnetize the material, and that ability of the field to magnetize the material was measured in terms of magnetic intensity. The wave field has got ability to magnetize. In the similar way, magnetic material has also got ability to get magnetized, and this ability of the magnetic material to get magnetized is measured in terms of magnetization. So I can say it is the ability of the magnetic material to get magnetized by the external magnetizing field. Right? Now let us define this particular term called as magnetization. Now what is happening over here? Here material is getting magnetized. That means magnetization is happening inside the material, right? So magnetization is defined as net magnetic moment produced per unit volume in the given magnetic material due to external magnetizing field. So student, magnetization is happening inside the magnetic material. And what is the reason behind that? The reason behind that magnetization is due to the presence of external magnetizing field, right? Now let us write this particular term mathematically. So I can write magnetization mz, it is equal to net magnetic moment upon volume, right? Now let us move further. So I can write vector mz, it is equal to vector mnet upon v, right? Where mz is the magnetization, mnet is the net magnetic moment, and v represents the volume of the sample. Now students, we have already learned a term called as magnetic moment for a bar magnet. Do you remember? We have learned this particular concept in 11th standard. So from that particular concept, I can write magnetic moment given by symbol capital M. It is nothing but equal to pole strength, which is small m, multiplied by the effective length of the magnet, or I can say that it is the magnetic length. So if I use this particular relation for the above expression, what will I get? I'll get small m into L effective into unit vector upon volume can also be written as area into length. So I can write A into L effective. Now students, there is a unit vector over there, and this unit vector provides us with the direction of net magnetic moment. Now see this expression carefully. Now we have one term in common. Which term is in common? L effective is common, so I can cancel out that term. So what will I get? I'll get small m upon capital A into unit vector. Now what is small m? Small m is pole strength. What is capital A? Capital A is the area of cross section. So from this particular expression, I can define magnetization in terms of pole strength and area of cross section. So let us define. So I can say magnetization can also be defined as pole strength induced per unit cross sectional area in the given magnetic material, right? So what can we say? It is the pole strength induced per unit cross sectional area in the given magnetic material. So students, up till now we have learned two definitions of magnetization. First one was net magnetic moment per unit volume, which is produced in the material due to external magnetizing field. And second one is, it is the pole strength induced per unit cross sectional area in the magnetic material due to external magnetizing field. Now students, these definitions are very important, right, for the concept, right? Now let us move further. Now students, tell me, magnetization, is it a scalar quantity or vector quantity? Now see the heading carefully, right? What can you say? Magnetization is a vector quantity, and what will be unit for it? Unit for it is ampere per meter, and you can also calculate the dimensions, and the dimension for this particular quantity is L raised to minus 1, M raised to 0, T raised to 0, and I raised to 1. Now students, do you remember this unit and these dimensions are same as that of magnetic intensity? So I can say that magnetic intensity and magnetization have same unit and same dimensions, right? Now students, in this particular module we have learned a very important quantity called as magnetization, right? I'll be seeing you in the next module. Till then, keep learning. Thank you.